In this video, we're going to discuss properties of the cross product. Now, if you recall, the cross product is the one where if you take two vectors, for instance, vectors A and B, you multiply them together and you get out another vector. So the right-hand side of this equation still has a direction associated with it. It's a vector. Now, if you recall, there are two ways of computing this. The first using components, which was that long formula, and the second if you're given magnitude and direction, where you compute the magnitude of the resultant vector first, and then you use the right-hand rule to compute the direction. Okay, so I'm not going to write all those out because they're too long. So we'll just go straight to the properties of the cross product. So the first is that A cross B is equal to negative B cross A. And you could convince yourself that this is true by thinking about using the right-hand rule. If you put your fingers along B first instead of along A first, you'll find that your thumb is pointing in the opposite direction. So B cross A is a different vector than A cross B. They are the negative of each other. So that's part of why you always have to be careful what you mean by the first vector when you're determining the direction of the cross product. Okay, next, if we're multiplying some scalar C by A cross B, we could first multiply the scalar by vector A and then take the cross product if we wanted, or we could take the cross product between A and then the scalar C times B. And these would all give you the same thing. Again, this is just telling you which order you're doing things in. Are we multiplying A by the scalar first, then taking the cross product, or are we taking the cross product and then multiplying the result by the scalar? And they all give you the same thing. We also could consider A cross B plus vector C, which is some other vector. And this is equal to A cross B plus A cross C. Where by C here, sorry if it's confusing, I don't mean this C, which is the result of the cross product. I just mean some other vector. All right, what happens if we cross a vector with itself? Well, this gives us 0. Why is that? Because the magnitude of A cross A is equal to the magnitude of A times the magnitude of A times sine of the angle between them, which is 0, right? A is parallel to itself, which means there's no angle between it. They're both pointing in the same direction. And sine of 0 is 0. So this is equal to 0. So whenever you cross a vector with itself, the answer is 0. What if we're just crossing two vectors that are not the same, but are parallel to each other? This still gives you 0, right? And for the exact same reason, A cross B equals A, B sine 0 when the vectors are parallel. So this is for A parallel to B. So even if they aren't the same vector, if they're pointing in the same direction, then the cross product gives you 0. All right, what if the vectors are perpendicular to each other, which is to say they're at a right angle? There's exactly 90 degrees between them. Then the magnitude of A cross B is the magnitude of A times the magnitude of B. And this is for A perpendicular to B. And that's because when two vectors are perpendicular, theta, the angle between them, is 90, and sine of 90 degrees is 1. So these are sort of the special cases you could consider when computing the cross product. Vectors that are parallel, which again means like they're both pointing in the same direction, or vectors which are perpendicular, which means that there's exactly a 90-degree angle between these two vectors. All right, and those are the properties of the cross product.